All right. So, valley and mountain breeze. Guess what? The valley breeze comes from the valley up the side of the mountain, okay? The mountain breeze comes from the top of the mountain down to the valley. And again, it's a matter of differences in temperatures. Now, one of the things we talked about in Unit 1, I know I keep saying we talked about it, but one of the things you already know is that if you climb a mountain, the air gets thinner. And as the air gets thinner, actually, it can heat up and cool down more quickly. It's kind of like your land relative to water. So that thin air, actually, when the sun comes up, it's ready to heat up. And as it heats up, it creates a low pressure, and that's why as the sun comes up, you have basically, and this next figure is going to show you, as the sun comes up, basically you have a breeze that's going from your valley up the side of your mountain. Now, when the sun goes down, then the opposite occurs. Basically, that thin air is going to cool down more quickly, create a high pressure because it's cooler, and voila, you have a downward breeze. Okay, so valley and mountain breeze. So this is your valley breeze. I can tell that because I have air going up the valley, and this actually is the mountain breeze where the air is coming down into the valley. This actually shows you, and maybe some of you guys have heard of these notorious ice storms, temperature inversions that can be kind of warm air pinned in the pockets of valleys in the Appalachians, the Carolinas. All right. Now, these don't have any names to say where they're coming from or anything, but oftentimes on my Unit 3 exam, I do pull in some local winds, definitely. Chinook, if you were to look it up, Chinook, and your textbook might even say this, I kind of lose track of which textbook says what, but it's an Indian name for snow eater. And I'll try to describe why would the Indians call this a snow-eating downslope wind. Okay, so it's on the leeward versus the windward side. And actually, these winds are just, if they're here in North America associated with the leeward side of the Rockies, we call them Chinook winds. If they are actually associated with the Alps, again, on the leeward side, we call them Foehn winds. They're the same. And this kind of talks you through maybe why they would call them snow-eating winds. Because one of the things we talked about is that actually as air descends, okay, we didn't talk a lot about it, but we talked about how ascending air cools down. Descending air warms up because actually that parcel of air is going to get smaller and smaller. Work is going to be done on it, so it's going to heat up. So it's a crazy sort of thing, but basically in a matter of not much time at all, if you are under the influence of a Chinook wind, you're going to see actually your temperatures get a lot warmer, as much as 40 degrees. Okay? And check out the winds. That's crazy too. So that's why they're called snow-eating winds. The Santa Anas. I'm going to go ahead and play this video. Let's see if I can do it from here. It is on the west side, in the Rockies, but it's on the leeward side. It's on the what we call the windward side. Okay. Katabatic winds. Katabatic winds I've not experienced either. Actually, they are associated with some sort of plateau formation that's cold. Both Antarctica and Greenland fit the bill. So actually what happens, it's kind of fun and it can reoccur. What happens is that air builds up, cold air kind of builds up over the surface of the plateau. And if you kind of think what a plateau surface is supposed to look like, I kind of think of this kind of as a plateau, okay? So it's got steep slides there. So basically you have air builds up here, cold air, these are both cold locations, it builds up here so it creates a high, and then basically it just builds up till it kind of sloughs off. It doesn't have to slough off both sides. But at some point that cold dense air basically falls off the side of the plateau, and then that falling air right there, that is your Katabatic winds.
Those are obviously super cold.
Well, as it descends, it warms, but it's cold. It's in the cold location, but okay. So country breezes. Actually, here again, finally, is the name. It tells you where it's coming from. So the country breezes are coming from the country into the city. So it's kind of a converging air to the city. And I didn't talk about it, but it was in your textbook, and I think they did a good job. One of the things that happens in the city is something called the urban island heat effect. Urban island heat effect. It just simply means that due to the nature of the city being mostly concrete, no plants and that sort of thing, that concrete heats up and retains its heat. Okay? So with that in mind, basically what we said, if it's hot, okay, then it's going to create a low pressure. So if these are my skyscrapers, this is my city, all right? Okay, basically it's warm, or I'll go ahead and I'll put warm because I can't put H for hot because I'm going to have to put an L here for if it's warm, it has a relatively low pressure. So then basically we have this, especially during the daytime and the hot of the day, we can have a country breeze coming in from the surrounding area. And actually this can kind of be a good thing because it has actually, well, maybe not. The air just kind of converges there in the city. When the sun sets, we can have the opposite. Okay. No. We can't. But what that can do, that converging air actually can keep the pollution in the city. What happens in the city stays in the city. Okay, so this is a good place to take a break. So we'll take a good long 15-minute break, and I'll be back here at 6:30, 5:30-ish, 6:30-ish.